Welcome to our HCF and LCM adventure, a simple, powerful way to make sharing fair and to predict when patterns line up. Imagine dividing toys into equal groups or figuring out when two blinking lights will flash together. HCF and LCM are the math tools that make those problems easy to solve. Over the next few minutes, we'll build the ideas step by step and keep everything clear and friendly. First, let's sort numbers into two big families: prime and composite. A prime number has exactly two factors, 1 and itself, so it can't be split into smaller whole number factors. Examples are 2, 3, 5, 7 and 11. 1 is special, it's not prime, and 2 is unique as the only even prime. Composite numbers, on the other hand, can be written as a product of smaller whole numbers, like 4 equal to 2 times 2, or 6 equal to 2 times 3. Understanding primes is the foundation for finding HCF and LCM. A classic old trick for finding primes is the sieve of Eratosthenes. Start by removing 1, then circle 2 and cross out every multiple of 2. Next, circle 3 and cross out its multiples. Then 5, then 7, and keep going. Any number that isn't crossed out at the end is prime. It's a fast visual way to discover all the primes up to any limit you choose. There are some neat special pairs to know. Twin primes are pairs of primes that differ by 2, like 3, 5 and 5, 7. A prime triplet is 3 primes separated by 2's. The only one that exists is 3, 5, 7. Co-prime numbers are pairs that share no factors other than 1. They don't have to be prime themselves. Examples include 4, 9 or 4, 5. Co-prime is all about having no common divisors except 1. Divisibility rules are like math shortcuts that save time. If a number ends in 0, 2, 4, 6 or 8, it's divisible by 2. For 3, add the digits. If that sum is divisible by 3, so is the number. To check divisibility by 4, look at the last 2 digits. If they form a multiple of 4, the whole number is divisible by 4. And any number ending in 0 or 5 is divisible by 5. These quick checks make factoring and other work much faster. A few more handy divisibility tricks. A number is divisible by 6 when it's divisible by both 2 and 3. For 8, check the last 3 digits. If those 3 make a number divisible by 8, the whole number is 2. For 9, the sum of the digits must be divisible by 9. For 11, take the alternating sum of digits, the difference between the sum of digits in odd places and even places. If that difference is 0 or a multiple of 11, then the number is divisible by 11. These rules are quick checks you can apply in your head. Now let's look at factors and multiples, two sides of the same coin. Factors are numbers that divide another number exactly, the numbers you multiply to get it. For example, 7 and 6 are factors of 42 because 7 times 6 equals 42. Multiples are what you get when you multiply a number by whole numbers. 42 is a multiple of 7 and of 6. When two numbers share the same factor, that factor is a common factor. For instance, 15 has factors 1, 3, 5, 15. 20 has 1, 2, 4, 5, 10, 20. The common factors are 1 and 5. The highest common factor, or HCF, is the greatest factor shared by 2 or more numbers. A straightforward way to find it is by listing factors. Take 32 and 48. The factors of 32 are 1, 2, 4, 8, 16, 32. And the factors of 48 are 1, 2, 3, 4, 6, 8, 12, 16, 24, 48. The common factors are 1, 2, 4, 8, 16. And the highest is 16. So HCF of 32 and 48 equals 16. Remember, the HCF can never be larger than the smallest number in the pair. And if one number divides another, the HCF is just the smaller number. The lowest common multiple, or LCM, is the smallest positive number that's a multiple of 2 or more numbers. One way to find it is by listing multiples. For 8, 16, 24, 32, 40, And for 12, 12, 24, 36, 48. The first common multiple is 24. So LCM of 8 and 12 equals 24. The LCM can never be smaller than the largest of the original numbers. And when numbers are co-prime, their LCM is simply their product. Prime factorization is the process of breaking a number down into a product of primes. And a factor tree is a helpful visual tool for that. Start with your number, say 96. Then split it into two factors and keep splitting any composite factors until every branch ends in a prime. Once you have all the prime leaves, you can write the number as a product of primes, often expressed compactly in exponential notation like 2 to the 5 into 3, depending on the result. There are two main methods to find the HCF. First, using prime factorization. Write each number as a product of primes, identify the common prime factors, and multiply those common primes using the smallest power that appears in each factorization. For example, 28 is equal to 2 squared into 7 and 72 is equal to 2 cubed into 3 squared. So the common prime is 2 with the smallest power 2 squared, giving HCF is equal to 4. The second method is the long division or Euclidean method. Divide the larger number by the smaller, then divide the divisor by the remainder and repeat until the remainder is 0. The last non-zero divisor is the HCF. For 144 and 180, that process gives HCF is equal to 36. There are also two practical methods to find the LCM. With prime factorization, you take every prime that appears in any factorization using the highest power of each and multiply them together. For 15 and 40, 15 is equal to 3 times 5 and 40 is equal to 2 to the cube times 5. So the LCM uses 2 to the cubed, 3 and 5, giving 8 times 3 times 5 equal to 120. The other method uses a ladder or repeated division by primes. Divide the list of numbers by any prime that divides at least two of them. Carry down numbers that aren't divisible and keep going until no further divisions are possible. Then multiply the divisors and the remaining numbers to get the LCM. HCF and LCM are linked by a neat formula for any two numbers. HCF times LCM equals product of the two numbers. That means if you know the HCF and LCM and one of the numbers, you can find the other. For example, if HCF equals 52 and LCM equals 312 and one number is 104, the other number is 52 times 312 divided by 104, which works out to 156. This relationship is a useful shortcut when you have partial information. To wrap up, remember when to use each tool. Use the HCF when you need to split or share things into the largest equal groups, like arranging items in rows with as many per row as possible or sharing toys fairly. Use the LCM when you want cycles or events to line up. For example, finding the next time two repeating events happen together or the smallest number divisible by a set of values. With prime factorization, divisibility rules, and both long division and listing methods in your toolkit, you're well equipped to tackle HCF and LCM problems with confidence.
That's it for today. Learn smarter with EduRev. Notes, tests, and practice in one app. Download EduRev now on Play Store and App Store and keep learning every day.